Welcome to ClickMyProject.com. A project title is the Vehicle Mounted Adaptive Traffic Sign Detector for the small sized signs in the multiple working conditions. This is an abstract development of the intelligent transportation system as a database for the environmental awareness depends greatly on the recognition of the traffic signs. The key issue with the current traffic sign detection technology include the complex working environment, poor small item detection, and challenging mobile deployment. This study makes a proposal for the vehicle-mounted adaptive traffic sign detectors for small-sized signs. In a variety of operational settings, long-range DSD can give the driver or autonomous vehicle enough response time, but it needs a model with a strong feature extraction capabilities for the small object. In our process, our main objective is to design a traffic signal using the CNN model for train the images and also deploy the program into the streamlit application for the verification of the traffic sign classification. Fit the model with accuracy of almost 98% and save the model for loading the model as the testing images. Objective: develop a traffic sign classifier. Develop a sign classifier for multiple working conditions. Improve the accuracy. Use the deep learning algorithms. This is a system architecture. From the image dataset, we want to pre-process the data and split the data. Extract the feature according to the classes. Classification: CNN algorithm is applied for the classification. In prediction, we want to predict whether what the class it is have, and the performance analysis, accuracy and loss. This is a flow diagram. From the image data set, we want to select the particular image and pre-process it and split the data and extract the feature. A classification using the deep learning algorithms and prediction, what type of class, and performance analysis, loss and accuracy. This is a use case diagram. From the user, first one is to select the data, pre-process it, split it and extract the feature, and classification, performance analysis. After executing a process, the program will execute in the console. The first one is the size of our image data set, and then this one is the splitting the data set as X train, Y train and X test, Y test. After build the model, we want to estimate the epochs. Here we give the 15 epochs for the valid accuracy as well as the minimization of the losses. And then this is a summary of our design model, and this is a graph between our validation accuracy and the testing accuracy, and this is a training loss and the validation loss. After training the Python code, we want to deploy the code into the streamlit application. Here is a home page streamlit application. We want to browse the images. First is the browse images. And then this is a predicted class as vehicles is greater than 3.5 tons is prohibited. And again we select one more images. This is a speed limit of 30 kilometers per hour.